Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 6, Fluency with Percents. Classwork opening exercise says to solve the following problems using mental math. Corey and Everett have collected model cars since the 3rd grade. Corey has 80 model cars in his collection, which is 25% more than Everett. How many model cars does Everett have? So, Corey. Let me change back to red for Corey. Corey has 80 model cars in his collection, which is 25% more than Everett. So first I'm going to start off by saying, let's talk about Everett's. Everett's car collection equals 100%. Corey's equals 100% with 25% more than Everett, which is 125%. Okay, so now I want to focus on Corey. So 125 divided by 25 is 5. Okay, so there are 5 25% in 125%. Okay, that's what I'm trying to say here. Corey has 80 model cars. So 80 is 25%. So if I take that 80 and divide it by 5, then I get 16. There are 16 cars for every 25%. And 100% is 4 25%, so 16 times 4 would be the number of cars that Corey has. So 6 times 4 is 24, 4 times 1 is 4, plus 2 is 6. So Everett has 80 model cars. So Everett has 64 cars. Corey has 25% more than Everett. Corey has 80 cars, and Everett has 64 cars. Example 2. 75% of students in Jessie's class are 60 inches or taller. If there are 20 students in her class, how many students are 60 inches or taller? Well, 75% can be represented as 3/4 of the class. So 3/4 times 20 students in a class. And when I multiply, this reduces to 5, and 5 times 3 is 15 over 1, or simply 15 students. Okay? So we can always change percents to fractions and then just multiply. B. Bobby wants to leave a tip for her waitress equal to 15% of her bill. Bobby's bill for her lunch is $18. How much money represents 15%? The easiest way to do a 15% conversion is to break 15% down to 10% plus 5%. Okay? Because 10% is really easy to find on a bill. So if I have $18 and I multiply it by 10%, which is 0.1, I get $1.80. It just moves the decimal one place to the left. So if 10% is $1.80 and 5% is half of 10%, then half of $1.80 is 5%, or 90 cents. When I add this 10%, so this represents the 10% and this represents 5%, which represents a total of 15%. And when I add these, 9 and 8, 17, carry the 1. Okay, 15% of the bill would be $2.70. Okay, exercises 1 through 3 are just that, exercises. So pause the video, see if you can do these. Unpause the video and check your answers. So here we go. Express 9 hours as a percentage of 3 days. So the first thing I want to do is convert 3 days into 9 hours. So 3 days times 24 hours per day equals, and I'm writing it like this to remind you of what happens to units of measurement when you multiply. So if I have 3 days times 24 hours per day, then the day is in the denominator, the day is in the numerator, and they cancel. And 3 times 24 is 72, and the H is still there, but the D's are gone. 72 hours. Okay, so now we want to know what 9 hours is to 72 hours when the 72 hours is 100%. What percent is 72? So I cross multiply. 72x equals 9 times 100. Divide both sides by 72. And I get x equals 72 goes into 90 once with a remainder of 18. All right, so let me do this off to the side. 72, 900, and 172, subtract, get 18. 7 times 2 is 14, so it would be 144. Subtract and get 36, or 360. And 7 times 5 is 35. 5 times 2 is 10. Carry the 1. I get 125. Okay, so 900 divided by 72 is 125. So 9 hours is, by percent, is 12.5% of 900. Okay, and let me explain the decimal place. 72 goes into 900, 72 goes into 900 12.5 times. So 12.5%. 9 is 12.5% of 72. Yes, that's correct. Number 2 says Richard works from 11 a.m. to 3 a.m. So if we are looking at a clock, 11 a.m. going all the way around to 11 p.m. is 12 hours. Going from 11 p.m. until 12 midnight is another hour. Okay, I'm just trying to figure out what this is. And then we want to go to 3 a.m., so I'm going to continue down 3 more hours to get to 3 a.m. So that is a total of 16 hours. That's a long shift. 16 hours. So he works from 11 a.m. to 3 a.m., which is 16 hours. His dinner break is 75% of the way through his work shift. What time is Richard's dinner break? I will represent 75% as 3/4, and I will multiply by 16. And when I do that, the 4 reduces the 16 to 4, and 3 times 4 is 12. So it's 12 hours after he starts. And he started at 11 a.m., so lunch is at 11 p.m. Okay, number 3 says at a playoff basketball game, there were 370 fans cheering for School A and 555 fans cheering for School B. Express the number of fans cheering for School A as a percent of the number of fans cheering for School B. That is where we have quantity equals percent times the whole. And the quantity in this case is 370 fans for A equals some percent of the whole, which is the fans cheering for B, which is 555. So when I divide both sides by 555, I get my percent to equal, let's see, these both end in 5. So I'm going to divide both of them by 5. 5 goes into 37 7 times. 7 times 5 is 35. Remainder of 2, so that'd be 74 over 111. Okay, is that right? Divided by 5? Yeah. I'm just trying to simplify this. Half of 74 is 37. Okay, so 74 divided by 2 is 37. So if I divide both by 37, hey Siri, what's 37 times 3?
37 times 3 is 111.
Okay, so 37 will go into 74 2 times. 37 will go into 111 3 times. So my percent is 2/3, which is approximately 66.7%. Or 66 and 2/3%. Part B says to express the number of fans cheering for school B as a percent of the number of fans cheering for school A. Now we're going to use quantity equals percent times the whole again. This time the quantity is the fans of B, 555, which equals P times, was it 370 fans? It was 370 fans. Okay, so in this case, we're going to divide both sides by 370. These cancel, and I get P equals. Now I don't need to do this again. I know that 555 reduces to 3 and 370 reduces to 2. So that is approximately 1. Well, let's not do an approximation. Let's leave it in fraction form this time so that it's going to be equal. So the percent is going to equal 3/2 or 1 and 1 1/2 or 1.5. And 1.5 is 150%. It says, what percent more fans were there for B than for A? Okay, well, if A was 100% and B was 150%, then that is 150% minus the 100%. Therefore, that is a difference of 50%. So there are 50% more fans cheering for school B than there were for school A. Number 4, a rectangle A has a width of 8 and a length of 16. Actually, let me do this way. Okay, there's our rectangle. A rectangle A has a width of 8 centimeters and a length of 16 centimeters. I always like to draw a diagram when talking about geometric shapes. Rectangle B has the same area as the first, but its width is 62.5% of the width. So, okay, so I have rectangle B, 62.5% of the width, so we're having a shorter width and obviously a longer length because length times width has to equal the same area. So it says rectangle B has the same area as the first. So 16 times 8 equals some smaller number than 8 times a bigger number than 16 to get the same product. Okay, so it says to express the length of rectangle B as a percent of the length of rectangle A. So if this is 8 centimeters, this width is 62.5% of 8. So 62.5% is 0.625. So this would be 8 times 0.625. That's what the width would equal in B. The width is 62.5% of 8. Okay, so when I calculate this, the width of B equals 5 centimeters. So I know the areas are the same. So the area of the first one, area equals, well, let me change it back to red because I'm talking about A. Area equals length times width. Area equals the length times the width. So the area of A is 6 times 8 is 48, carry the 4, and 8 times 1 is 8, plus 4 is 12, 128 centimeters squared. Express the length of rectangle B as a percent of the length of rectangle A. Okay, so now we want to find the length of B. So now over here we would say area equals length times width. And this is where writing a formula every time helps you decide how to do this. Over here I didn't know the area, but I knew the length and the width, so I can find the area. Over here we know the area and the width, we need to find the length. The area is equal, so it's 128. We don't know the length, but we know the width is 5. So when I divide both sides by 5, I find the length. 5 goes into 12 twice, remainder of 2. 5 goes into 28 5 times with remainder of 3. 5 goes into 36 times, so it's 25.6 centimeters. So it's a 25.6 centimeters. So that's my length of B. Okay, I haven't answered the question yet though. It says to express the length of B as a percent of the length of rectangle A. So now we're going to do the Q equals percent times the whole. So the quantity we know is 25.6 equals some percent times the whole length, which would be the length of A, 16. So in order to solve this, I divide both sides by 16, and I get P to equal, well, half of 25.6 is 128 over 8. I can reduce that to 64 over 4, 32 over 2, 16. Okay, because 256 divided by 16 is 16, but there's a decimal place. So P, the percent, is 1.6. So if we take that 1.6 and multiply it by 100%, we get 160%. So the length of rectangle B is 160% the length of rectangle A. Number 5. A plant in Michaela's garden was 40 inches tall one day and was 4 feet tall 1 week later. So 40 inches, and I want to change feet to inches because we can't do conversions if there's a difference in our unit of measurement. And there are 12 feet times, actually 12 feet per, hang on, let me get this straight, 12 inches per foot times 40 inches. Okay, let me fix that. I'm looking at the wrong value here. I want to convert the 4 feet into inches. So it's 12 inches per foot times 4 feet. And my feet cancel and I get 48 inches. So there's 48 inches tall 1 week later. By what percent did the plant's height increase over the week? So we want to use our quantity equals percent times the whole. And our quantity is, let's see, 4 feet is equivalent to 48 inches. It's 12, 4 times, okay, 40 inches is the whole. So we're trying to find, so 40 inches is the whole. So it's percent times 40 equals some quantity. Okay, so it grew from 40 inches to 48 inches, which is a difference of 8 inches. So our quantity is 8 inches, the amount it grew. And then when I divide both sides by 40, I get the 40s to cancel, and my P equals 1 over 5. That reduces to 1/5, which equals 20%. Number 6. Lorraine must obtain a minimum number of signatures on a petition before it can be submitted. She was able to obtain 672 signatures. which is 40% more than she needs. How many signatures did she need? So 40% more than she needs. She needs 100%, and she got 40% more, which is 140%. So 672 is 140%. So if I wrote quantity equals percent times the whole, our quantity was 672. Our percent is 140 times our whole. But 140 as a percent, 140% as a number is 1.40, or just simply 1.4. If I divide both sides by 1.4, then these cancel, and I get W to equal 14 and 14 is 28, 4 would be 56, so it would be 4. So what I'm doing here is 1.4 goes into 672 how many times? Well, I'm going to move the decimal one place, so I'm going to add a 0. 14 goes into 67 4 times. 56, 1, 1, bring down the 2. 14 goes into 112 8 times. 8 times 4 is 32. 8 times 1 is 8, plus 3 is 11. No remainder, so it's 480. So she needed 480 signatures when she got 672. Okay, that is the end of lesson 6. Review this lesson summary and go do your problem set.